Just a brief about what I'm up to now. I left Edelweiss 2 years back and set up my own venture, HR Invest Trade and Arc Capital, where we are doing algorithmic trading and everything related to algorithmic trading for prop traders, brokers, hedge funds, HFTs, for everyone. Right. Everyone good? Can we begin? So I'm just going to start off with some basic jargon and myth busting. You must have heard a lot about machine learning, AI, and everything would be a little hazy in your mind. So I'm going to start with artificial intelligence. It's basically a broad concept where machines can think or carry out tasks in something that we would consider smart or something with common sense, right? Within artificial intelligence, there are two fields. There's applied AI and there's general AI. Applied AI examples of that would be systems designed to intelligently trade stocks or shares, maneuvering of an autonomous car, which we're reading a lot about. That would be applied AI, where you're using AI techniques on a specific problem. Generalized AI is more exciting, or where all the latest development is happening. It's a field where systems can handle any task. That is like they develop common sense, quote unquote, right? Now, what is the difference between AI and machine learning? So machine learning is nothing but just the current state of the art techniques that we use for AI. The whole idea is not to program everything on how a machine should do a task, but give the machine data and let it learn for itself. We'll go deeper into how this happens. You must have heard of some other catchphrases like big data, right? So with the advent of the internet, there's a huge increase in amount of digital information being generated, stored, and made available. So any data set which cannot be handled with traditional database tools, so your basic SQL databases or your Oracle databases, which they can't handle, that's what big data is. And you have this whole variety of cluster-based tools like Hadoop, Spark, Cassandra. You must have heard of all these buzzwords. That is big data. Neural networks is basically a model of machine learning. So in the 1960s, basically we realized that rather than teaching computers how to carry out each and every task, it's far more efficient to teach them how to learn for themselves, or basically code them how to think like a human being. So neural networks is one of the major innovations in this task. They quote unquote think the way we do, and with the innate advantages of speed, accuracy, and lack of bias, right? Deep learning is nothing but more sophisticated in terms of depth and structure forms of neural networks, right? And NLP, or natural language processing, is just a computer's way of understanding the nuances of human language and learn to respond in a way that an audience can comprehend. Examples of this would be it can read some text and figure out if a person is making a complaint or offering a suggestion. I can listen to a piece of music and figure out whether it's likely to make somebody happy, sad, and also find other music which can match the mood, right? So that's the use case of NLP, and that's what NLP is. So I'm just going to start with a game of fact and fiction, right? So I'm going to be using AI and machine learning interchangeably, so pardon that. So this is one of the common perceptions that machines are smarter and better than humans. Is this fact or fiction? This is fiction. It's not the case. So the media basically loves portraying AI as machines versus humans. Like Arnold Schwarzenegger in the movie Terminator, right? But in reality, machines and humans have very different and complementary capabilities. So just take a look at this picture. Humans are much better at the task on the right hand side, which is find the leopard print dress, where humans are great at discerning meaning and context out of a problem. And a machine would be much better at the task at the left, which is finding eigenvectors from any data, which is machines are much better handling structured computations. So it's a complementary skill set and different capabilities. The best blend we found is to blend these two together and not one approach versus the other. Okay, one more critique of machine learning is that it's just data mining, right? Uh, therefore it finds spurious patterns. There's a classic example in the stock markets that somebody found the monthly moon tides have a very good correlation with stock market performance, right? But in most of the cases, the problem usually lies with the data scientist rather than machine learning techniques itself. And just to explain it further, machine learning is excellent at finding sophisticated patterns in data, right? And the two main advantages over humans is one is non-linear patterns, and second is complex dependence between variables. Now, what does this mean? Let me take an example. So everybody knows about price to earnings ratio, right? It's a valuation metrics. You decide how cheap or expensive a stock is. And if you think about it, you would usually think that more expensive stocks or high PE stocks will give you lower returns, and cheap stocks, or at least the proponents of value investing will tell you this, the cheap stocks will give you higher return. So this, what I've plotted on the screen, is typically what your mind would visualize when you're looking at PE ratio. When you look at historical data for India, it's not the case. You see on the left hand side there's a small bump. It's a hockey shape curve, not a straight line. So this basically says that the most expensive stocks tend to do well because of momentum and other factors. Now again, you can argue that a human can look at this and do it themselves manually by plotting this. So what's the big deal? The big deal is if you have a few data points and a few variables, this is very well possible humanly. But imagine you have millions of data points and you have thousands of variables. There it becomes intractable for a human to do it, and that's why machine learning helps us find these patterns. The second example of complex dependence is this. So there are two variables that I've plotted. So the y-axis, sorry, for the people who can't understand this, the y-axis is the returns, and the x-axis is the deciles. So the bottom decile returns to the top decile returns. Quintile returns. So if you look at these graphs, you see no clear trend, right? On the left-hand side, you have the volatility, and on the right-hand side, you have the beta. So a human would discard these variables if you're visualizing this and say that these features are absolutely irrelevant. Okay, but when you apply a simple feature combination algorithm, it combines both these features and gives you a new combined feature. And as you can see, there is a trend which emerges out here. So just using an FC algorithm, even the irrelevant features can become relevant because machine learning understands interdependence between variables, which human would overlook. Okay, so another common talk point about AI is AI models are self-modifying. So I'm just going to tell you about a joke that I heard, right? So this is actually true. Warren Buffett was visiting India, right? And Rakesh Jhunjhunwala is sitting next to him in the flight. This is a hypothetical. This didn't happen. Don't quote me on this. Now, Warren Buffett is landing in Mumbai. And just before, whoever's from Mumbai will know this. Just before you land in Mumbai airport, you see Dharavi, right? So Warren Buffett is looking down at Dharavi and he asks Rakesh Jhunjhunwala, "Okay, what is this?" So Rakesh Jhunjhunwala just coyly looks at him and tells him, "These are short sellers." So in this kind of market, this is just to give you an example of being, a fund manager's style risk, right? Like a fund manager, if he's a value investor, he'll look for value in all sorts of markets. Value investing works great, except if it's a bull market. In bull markets, growth investing does well, right? And the human mind is not able to easily shift or adapt to these different market situations, and that's what AI models are brilliant at. They quickly adapt to all the market states. So this is something that I'm putting out. Machine learning can predict black swans, previously unseen events like the subprime crisis, right? Fact or fiction? This is indeed a fact. Now you can naturally think that if something has never happened before, its predicted probability must be zero, right? If your machine learning algorithm is just mining the data, it's never found this pattern, how can it predict it? On the contrary, machine learning predicts rare events with very high accuracy. Just to give you a logical example now, if A is one of the causes of B and B is one of the causes of C, an ML algo will figure out that A can also lead to C, even if in the past we've never seen A cause C in the past, right? I'll give you a few examples now. Everybody uses Gmail, right? Now the spam filter of Gmail every day will correctly flag new concocted spam emails, right? Even if a spammer will change a few words here and there, you must have seen some spam removing some vowels from the letters, etc. Even the black swan event, like the housing crash of 2008, was widely predicted by machine learning algorithms, just not by the flawed risk models that most of the investment bankers were using at that time, and hence we had the subprime crisis, right? Another critique is, okay, now this all sounds good, but AI is only for technological elites, like the Googles, the Amazons, who can sink hundreds of millions of dollars, assemble large teams of machine learning experts, right? This perception is absolutely wrong. Today, with the advances in computing, cloud computing, technology available, it's possible to start and apply AI to any one of your business processes for less than 5 lakh rupees, right? This is the last myth buster that I'm going to talk about. It's the more data you have, the more likely you'll hallucinate a pattern or cook up a pattern which really isn't there. So just to give you an example, there was a common critique that the more phone records, so everybody knows that after Edward Snowden, that NSA snoops on your phone records, right? NSA is listening, Big Brother's listening. So the more phone records NSA looks at, the more likely it is to flag an innocent person as a potential terrorist because he accidentally matches some terrorist detection rule. On the contrary, this is not true. The more data that you have decreases the risk of such a thing happening because the rules which are learned have stronger support. ML can find patterns involving multiple features, which makes them more robust instead of using singular features. And ML is very efficient at eliminating irrelevant features. So to give you an example, a person videotaping a New York City hall may not be suspicious, and another person buying large quantities of ammonium nitrate may not be suspicious either. But if the two are friends or in close phone contact, perhaps the FBI should take a look, right? It's not a bomb plot. So putting these different variables and different entities together is something that machine learning can very well do. Great. So before I get into use of machine learning in trading, I just want to show you a video which showcases the power of machine learning and where all is being used in the world.
Artificial intelligence, harbinger of doom, destroyer of jobs, and pure science fiction. In a world of fake news, be careful what you believe.
In fact, AI has been running in the background for over 60 years.
And the robots haven't taken over just yet. In 1950, Alan Turing gave us the Turing test to gauge whether a machine could think like a person. Christopher Strachey created the first AI program in 1951.
And in 1996, IBM's Deep Blue became the
First chess-playing computer to defeat a reigning world champion.
Today, AI is no longer the plaything of governments and corporations.
It's an undeniable part of everyday life. From Google search and Spotify song recommendations to X-ray analysis and Alexa, machine learning is touching and augmenting every aspect of our lives.
But this moment, right now, is unlike any other in the history of AI. We're heading towards a revolutionary transformation, and the pace of change is accelerating.
Imagine a world without traffic jams, where cars drive centimetres apart, freeing up road networks. Imagine safer streets, where AI help police officers predict with an accuracy of 98% whether a criminal will reoffend if released on bail. Imagine people living longer, healthier lives, thanks to faster, more accurate diagnosis. Motor insurers that use real-time data to prevent tired drivers from having accidents.
Banks using facial stress analysis to automatically detect ATM fraud.
Virtual independent financial advisors that work proactively on your behalf 24/7 for free.
Previously unthinkable levels of customer experience are the new normal.
This is no longer the stuff of science fiction. This is quickly becoming the reality of AI. AI is already augmenting human functions, and its advance within business environments is truly exponential. Using AI to redefine financial products, processes, and growth is very much a consideration for now. For business leaders, there are strategic actions to be taken today that will help ensure your business is still relevant and competitive tomorrow. Virtual employees will augment the human workforce, freeing up people to do more satisfying, higher value tasks. Processes that once took whole days will take only minutes.
And AI will soon be unlocking trapped value in your data. New markets will be created and existing ones redefined.
Productivity will be transformed. The impact on your business and your customers will be revolutionary. With such a great opportunity comes an equal risk. Those slow to begin tactical AI projects now will ultimately be left behind.
Whereas those who start their journey soon will reap the rewards.
Now is the time to lay the foundations of your firm's AI-driven future. Advances in AI will not merely change the way financial service providers operate, they will revolutionize the lives of stakeholders, customers, and employees forever. And the first to move will become the leaders.
So let me ask you this. Do you want to embrace AI now, or wait for your competitors to embrace it first so you're left behind?
AI is here. Where are you?
Everybody knows, Google kids started in a basement and they've revolutionized search, right? Meru cabs was synonymous with hailing cabs earlier. Now Uber, Ola have taken over. You don't hear of Merus anymore. So the basic point is new technologies, new way of looking at things. You don't adapt, you get left behind, right? So let's talk about machine learning, a basic introduction for trading. So traditional programming, what people think of coding, programs, machines is this, right? You give it some data, you give it a program, the computer computes it and gives you an output, right? So for example, the program is A plus B. The data you give it is 1 plus, A is equal to 1 and B is equal to 2. So it will do 1 plus 2 and give you 3 as the output, right? Now, how is machine learning different? Machine learning, the flow is the opposite. So you will give a machine learning algorithm 1 and 2, and you will give it the output 3. And the machine learning algorithm will figure out that it's supposed to do 1 plus 2, right? So that's the difference. You give machine learning the data, you give it the expected output, and it will give you the rules that you should follow. I just want to talk about what machine learning can do for trading. One, it can uncover quote unquote hidden patterns, as I explained to you in the past, non-linear patterns, and where variables are interdependent. It can find these. So as an example, I took 5 fundamental analysis variables, which is mentioned in the slide. Your price to earning ratio, your dividend yield, your return on equity, which talks about how profitable a company is, your institutional holding, which tells you who's buying the company and what smart money is doing, and your profit growth, which tells you how the company again is growing. And I threw this at the machine learning model, and I asked the ML model to find patterns which can separate profitable stocks from loss-making stocks, right? So here again, I'm giving the machine the inputs, I'm giving the machine the expected behavior, and I'm expecting it to find the patterns and give it to me. So this is what came out. This is a basic decision tree model. So this is what came out. So as you can see, the green arrows, the blue parts are what it found a pattern to buy. So a stock with low institutional holding, with high dividend yield or dividend yield more than 1%, which is cheap. So PE ratio less than 7.7. That was a buy. That was the strongest buy signal. So again, a company which is not discovered by institutions, which is paying good dividends and it is available for cheap, that it told me you should buy. And on the other side, if you can follow the red arrows, a company which has a lot of institutional holding, PE ratio is not less than 6. So PE ratio is more than 6, it's expensive. Institutional holding is high, but not very high. It's less than 30%, which is not growing. The growth is, zero or negative. It's not even paying dividends. Dividend yield is less than so 70 basis points. That's a sell. So again, the machine tells me that a company which has institutional holding, not too much, which is not growing its profits, which is not paying dividends or high dividends, sell those companies, right? So this is what a machine learning algorithm throws at me. Second experiment I did was, a lot of people think that is machine learning algos, is algo trading and machine learning the same? So basically, to put that in perspective, I want to showcase how machine learning algorithms learn and get smarter over time. So for this, I basically did a horse race between an algo strategy. The algo strategy is quite simple. You buy cheap stocks where the PE ratio is less than 15, and you sell the stocks when they are not so cheap, when the PE ratio goes above 15, right? This is a tried and tested value investor strategy, right? And then I made a machine learning model, which is again a very simple decision tree model based on the same PE ratio, return on equity, dividend yield, and growth. Okay, same factors. I threw these parameters of the machine learning model and asked it to learn what rules should it develop. The universe I've taken for this experiment is the top 50 stocks in India based on the highest market cap within each sector. So there's one stock representing each sector. I did this experiment for 10 years between 2004 to 2014. I took monthly data and quarterly rebalancing because most of these are fundamental factors and companies report or changes happen in these fundamental factors every quarter, right? Portfolio was made by equal weightage. I've not done anything fancy. There are no stop losses, and this is walk forward backtesting, which prevents curve fitting or any of those look ahead biases, right? I don't want to go into the details of walk forward testing right now. If anybody has any doubts, we can take it after the session. This is just a glimpse of the list of companies. So you have your Reliances, Tata Motors, ITC, Infosys, HDFC Bank, all the big companies there. So this was the portfolio equity curve. On the y-axis, it's how your portfolio has grown, the portfolio value, and the x-axis is over time. So from 2004 to 2014. The blue line, if you can see my screen clearly, is the algo strategy or the PE strategy, which is not done badly. It's done well. Your equity has grown to 30x over 10 years. Not bad. And the orange line is the machine learning strategy. So you can see in this, if you look at the period highlighted in green, the algo strategy in this period in the first 1 year does a lot better than the machine learning strategy. And this is the model formation period. So any machine learning strategy in the beginning is going to be underperforming. It's going to be crappy. It takes time to understand and learn. So this is the model formation period. Okay, so we were on the portfolio equity graph, right? I just explained the model formation period where the algo strategy beats the machine learning strategy. And the interesting part is this, where the orange curve, if you see, it's flat during the bear markets, and 2008 to 2009, 2011, 2013. And the algo strategy cannot adapt because it's a static strategy. So it gives away a lot of its gains. Another interesting thing you can see is in 2007 and to 2009, it's a big bear market which the ML algo learns to stay out of. And if you see the 2013 period, it's a very small correction which the ML strategy learns to stay out of. So as you can see, over time, the strategy learns to stay out of smaller and smaller and smaller corrections, and not just the big bear markets, right? So as you can see, the ML is getting smarter over time, right? Just to make that point even clearer, on the left, you can see the drawdown chart. On the y-axis is the drawdown, and on the x-axis is time. On the left is the algo strategy, and on the right is the ML strategy. If you can see the algo strategy, the drawdown of the index, which is the green line, and of the algo strategy, which is the blue line, is more or less similar. And if you look at the graph on the right, the index is the green line, but the blue line, the ML strategy in the areas which I've highlighted as in red, the ML strategy doesn't face the same drawdowns because it learns to stay away from these, right? And just to look at, the summary statistics of the strategy, I've compared the ML strategy, the algo strategy, and the index. So both the ML and P strategy outperform the index. The index is on 18% in this period. The algo strategy does 37%, and the ML strategy does 46%. But the ML outperforms the algo strategy, right? In terms of exposure, which is the amount of time that the strategy is in cash versus invested, you can see the algo strategy is in the market 100% of the times, and the algo strategy is in the ML strategy is in the trade only 2/3 of the time, or 67% of the time. On the win-loss ratio, also the ML hit ratios are much better. The algo strategy has bigger wins, but also bigger losses. The ML strategy is more consistent. Risk metrics of the ML strategy system is much better. Only 20% drawdown versus 65% drawdown for the algo strategy, and 60% for the index. On a risk-reward basis, ML is the clear winner. Again, I'm not showing you this to tell you that ML is better than algo. It's just to help you understand. I'm not trying to profess one way of trading the market versus the other, but just show you the difference between ML and algos, right? Another difference is that machine learning can detect hidden states of the market. So this one experiment that I did, there is a model of algos called the Markov regime switching models, which can detect these hidden states. I did one experiment where I gave the MRS model Asian Paint stock, and I asked it to detect the phases bull, flat, or bear markets. So the green line is the detected regime. If it's high, that means it's detected as a bull market. If it is in the center, somewhere between 3 and 4, it's detected as a flat market. And if it is low, it's detected as a bear market. So as you can see, it does a decent job. It's not 100% accurate, of course. No ML strategy is, but it does a decent job at detecting this. A second experiment I did was to detect not just price movement, but you can also detect volatility periods. So again, I took Asian Paints and I tried to detect high and low volatility periods. So when the green line is high, that it shows as a high volatility period. When the green line is low, it shows as a low volatility period. For example, you can see between 2002 and 2006, it's showing a low volatility period when the market is one way direction going upwards, right? But without too much of volatility. And in the correction between 2007 and 2009, it's showing a high volatility period because there's a correction. The third advantage, model behavior adapts depending on the hidden state. So I've just plotted which features the ML model is giving more importance to in different market phases. So if you can see in the bull market, the return on equity and the profit growth, it says is more important. But valuation, which is measured by PE ratio, the graph on the bottom left, in case you guys are lost, is the least important feature. So markets, stocks which are cheap don't do really well in bull markets. And in bear markets, the bottom right, if you see the graph, it tells you that growth and stocks where there's a lot of institutional holding do well, and those are important features. And valuation and dividends are not really important in bear markets, right? This is just the rules which adapt based on the hidden state. So in a bull market, you can see the rules are very different from the bear market. What rules the machine learning model uses. I want to discuss the third use case with you guys is how ML can be used to augment a human trader, right? So, and it can be used to augment both discretionary as well as systematic traders. So a friend came to me and he said that I have a technical indicators based systematic or algo trading system. It's a momentum system which uses various entry signals and filters. He was very happy with the system performance. It was giving him good money, but it had only a 40% hit ratio. So he came to me and he said that, oh, tu to ye ML karta hai, so do something to improve this ratio. So what we first looked at was, are there any patterns in the losers? So all the trades which turn out to be a loss, which I can avoid, are all the indicators that he's using. So are they all equal value? So what he was doing is he had 5 confirmatory indicators and 1 entry indicator, and he was giving equal weightage to all these indicators to take a final decision to buy or not. So that's one problem as well. People argue that just doing a stepwise selection, which basically means that I add one indicator at a time, backtest it, and see that if my profitability or risk metrics are improving, will tell me whether this indicator is good or not, whether I should add it or not. The problem with that approach is that it ignores the feature dependence. So if indicator A is good and indicator B is good and indicator C is bad, it doesn't mean you should eliminate C, because B and C together might be better than A, right? So that dependence between features it ignores. So this is what I did. I added a machine learning filter between his signals and his trades to filter out the low probability trade. So his trading system gave out buy sell signals. It went to the machine learning system, which basically told him that which of these signals to act on and which ones to not act on, depending on a prediction of whether this signal is going to be a profitable trade or a loss-making trade. And only the filtered trades went to the market. Again, as I was discussing feature importance, I saw all the features he was using, and only like the top 4 or 5 features were important. The rest of them were meaningless. So on the y-axis is how important the feature is, and on the x-axis is all the features that he was using.
Okay, Rishabh, there are a couple of questions. If you could take them now.
Sure, please.
Okay, so previously in 3-4 slides back, you talked about Markov model. So Krishna was asking, is the Markov model in R or Python? How did you build it?
So in both R and Python, they are very rich languages for data science and machine learning. There are a lot of inbuilt packages available. If there are no standard packages, there are always projects on GitHub where people have implemented these. So you don't need to reinvent the wheel and code them yourself. They're available. You just need to figure out how to use it, in what situation to use it, and you can use it. I don't want to go into too much mathematical depth of Markov models right now because of limitation of time. Saurabh is going to announce a more detailed course that we're going to be launching, where we go into the depths of all these models.
Thank you. And Gangadhar is asking, have you taken into consideration survivorship bias while presenting backtested results?
So that's a very good question. In machine learning, there are a lot of biases, there are a lot of issues, and you have to take care of all of them. In the backtesting, I have taken care of survivorship bias. I've shown you the list of stocks, also the 50 stocks which I've taken as universe. It's the same 50 stocks for both the systems. And these are stocks which have survived for the 10-year period, right? So that is taken care of. But it's a very good question, and there are a lot of challenges and biases like survivorship bias which you have to take care of.
Thank you. And Ritesh has a question which I think the answer everyone wants to hear. So he's asking, I am an IT professional with 4 years of experience. How can I build my career in the field of system stochastic trading and strategy building?
For any person getting into systematic trading or quantitative investing or trading, there are three basic pillars that you need to not master, but at least have a decent handle on. One is technology. So you need to be able to code, not high performance computing kind of coding, but more coding which a data scientist uses. So something, you pick a language like Python or R, and you should be able to code in that. So technology is one aspect. Quantitative quant or statistics is another pillar. So your standard distributions, your time series analysis, econometrics, all those things, probability theory will come there. So some basic statistics you need to know. And the third aspect is obviously trading. You need to have a trading sense or a knack to know where the opportunity is, what kind of strategy I can use. So these are the three things you need to master. I can share offline a list of resources which you can use, which are available to build strength in all three.
Yes, the list of resources would be very useful, Rishabh. Please do share with me, and I'll share with the participants then.
Will do.
Okay. And Devanshi is asking how to apply machine learning, like how to learn implementation, and how much time does it take for a total novice to learn it?
Okay, so it depends on how dedicated you are, but if you are dedicated, which I'm assuming you are, I would say 3 to 6 months is a good time to get the handle on the basics and start implementing machine learning projects. In fact, I can just take you through a good starting point would be, we're launching this course with AlgoG. It's available on AlgoG website on machine learning, where we go through all the implementation from start to finish. It's a 2.5 month course, so you can go through the curriculum, which should get you a very good handle on starting to implement these things.
Thank you. And Shetty is asking, has machine learning been used successfully for intraday trading?
That's a very good question. And so the frequencies in which machine learning is better is the frequencies in which humans are worse, right? Intraday trading, where you have to crunch a lot of numbers and a lot of information, which a human cannot find possible to do, you find a lot of inefficiencies, and machine learning, in fact, is the best at lower frequencies. At higher frequencies, at intraday, maybe second level, minute level frequencies. And frequencies like long-term investing, where there's enough time for a human to analyze and go into the depth of analysis for each stock, balance sheet analysis, P&L, cash flow, etc. Machine learning adds value, but not as much as not much of an edge as you can with intraday trading.
Thank you. And Akshesh is asking, can you elaborate walk forward? So I don't think that would be possible in, we are about to come to the finish time, that's 9:30. Rishabh, could you answer that?
Walk forward is an advanced backtesting method, which basically helps you avoid what we call forward-looking bias. So let me just tell you a brief about that. It is just, now if I'm training my machine learning model from 2004 to 2014, my model will be very well built for that period, right? Now, if I backtest on the same period, I am basically cheating. So what walk forward does is, I will train my model from 2000 to 2004, then predict on 2004 to 2005, and use that 2004 to 2005 to calculate my performance. Similarly, I will shift this window from 2001 to 2005 to train, and predict from 2005 to 2006, and that's how it walks forward. But we can go into more details. It's a 15-minute discussion to explain this in detail, so we can go to more discussions in the course.
Thank you. And Shetty is asking, is clustering better approach than Markov models for regime detection?
You can use clustering for regime detection. It is possible. Yeah. But the problem with clustering is it will cluster. So clustering is a different kind of animal. Clustering will tell you which are similar kind of market regimes. But again, so you give a set of features and clustering will tell you which stocks are similar or which time periods are similar, but doesn't mean if you want to find price trends, clustering will tell you that. Regime switching models are much better at finding that because there are defined states or defined regimes. In clustering, there is no defined state. It just finds nearest neighbors or whatever algorithms are used. It just finds similar groupings together, but without much of a understandable logic. Why?
Okay, and Krishnan is asking, when are you guys launching this course? So, it's available right now on the Algoji homepage. To the top navigation menu under education, you can, and there are a lot of questions raining in. That shows, the enthusiasm of the participants. I'm really thankful to you all for taking this session so enthusiastically. And now Ritesh is asking, is there any standard certification program in this field?
There are a lot
Rishabh, could you answer that?
Yeah, there are a lot of certification programs for machine learning, but applying machine learning for trading, I don't know of any course for India. There are a couple of courses for US markets, but for India, I don't think there is anything of this sort. So
Actually,
again,
yeah. Continue,
go ahead.
Rishabh. Yeah.
Go ahead.
So actually, Ritesh, so actually, while creating that course page, I was looking on kind of course, and actually, I was surprised that such course has never been launched in India, which talks machine learning use cases relevant for India, because US markets are pretty different in their characteristics also.
I think just to add on, one more reason is it's a very well guarded secret, or is the current cutting edge methods for financial markets. So not a lot of people want to expose this to everyone.
Right. And machine learning model you showed, when special event happen like bonus pledge, open offers, buybacks, how will machine learning program take care of it?
So it's a good question. Machine learning doesn't take care of it. With a machine learning model, if you put garbage in, you're going to get garbage out. So you have to be very careful of giving the machine learning model good, clean data. So for any machine learning project, any good data scientist will tell you that 70% of your time goes in cleaning, preparing the data, and only 30% time goes in the actual machine learning part of the process.
Okay. And Akshay is asking, on what software can we install machine learning? How can machine learning be applied?
So machine learning is a tool, it's not a software. You have to build the models. You can build it using, I would recommend Python or R, because they are industry standards and there's a lot of rich support for these two packages, languages. Sorry.
And Deepan is asking, if you build your own machine learning algorithm, are there any legal or compliance approvals required to execute them? So this I could also probably answer, Deepan. What the exchanges are and what the SEBI is concerned, that no one should manipulate the market. So the approvals or compliances are to ensure that how your order execution, how you're pushing orders to the market, and you're not manipulating. So if you're just building an algo like some use cases Rishabh has shared, that is not market manipulation. That does not require any special branch approval. Okay, and that does not even require 100% automated trading, because not all machine learning systems are intraday or high frequency. There are low frequency trading system also can be built using machine learning, and you can actually execute those trades manually. Okay, and Sanjay is asking, which all machine learning algorithms are used for swing trading?
So that's a very long discussion, Sanjay. I would not be able to cover that in the given time. But broadly speaking, machine learning, which algorithm to use for what problem is something we are going to discuss in detail in the course. It's a topic for which I have kept 1 hour in the course, and I don't think I can do justice on it in like a few minutes now.
Okay. Any software where I can feed data for selected parameters for a machine learning model?
So it's a good question. So this is the true beauty where you need to combine a human with a machine learning model. The parameters or the features is something which comes from your the data scientist and the domain expert have to sit together to come up with this. It depends on your understanding of markets. What features you use will determine how good your results are. So there's no standard way of determining what features to use. It depends on your domain understanding and your understanding of data science. But this is the most critical part of machine learning.
Okay. And Akshay is asking, does machine learning work well in option premium analysis?
Machine learning works a lot better. I'm not a lot better, but it's a lot more useful for options trading. So let me just answer this simply. The more complex your problem is for the human mind, the better machine learning will work on that, because you'll have an edge which a manual discretionary trader or a simple systematic trader will not have.
Okay. And Ritesh is asking, is it possible to implement machine learning concept in individual trading, or is it suited only for industry level like hedge funds? So Rishabh, could you answer this, with 1 or 2 use cases? I mean, you could just mention like.
So it's very much possible. One of the myths I said that it's not for the technological elite.
Okay, and what about individual level? I mean, a total starter who does not want to invest, say, more than 10 or 20 in technology. I mean, who just wants to learn and who just wants to build a Python-based algorithms in his laptop.
Sure, you can definitely do that. It just is a little time-consuming, but if you're willing to invest that kind of time, you can definitely do that. Most of the tools required for machine learning are you get a lot of open source free tools available. Python is free. All the packages of Python for machine learning are free. They're open source.
Okay. And Monotosh is asking, is the PPT complete? No, Monotosh is not complete, but Rishabh, it was kind of Rishabh to actually pause for such long and to cover as many questions as possible. There are still few questions. Rishabh, can you cover them now, or would you like to take them at the end?
We'll take them at the end because a very interesting section coming up ahead.
Okay. So please continue, and please keep putting up your questions, and Rishabh will take all of them again in one go after that interesting section.
Great. So this slide basically just tells you about. So Eureka Hedge is a global standard which measures the performance of hedge funds globally. You can just see this slide. It's just comparing the performance of different kind of hedge funds over the years. So the blue line, which is the top performing funds, they are basically hedge funds which use AI and machine learning in some form or the other. All right, so this is the important section for anybody starting machine learning. There are a lot of common mistakes that I see most of the beginners making, right? So without getting too technical into these mistakes, I'll just introduce you to them, these common mistakes in an easy to understand able manner, so that to beware of these. Okay, so I'm going to give you an example. A friend of mine came to me and she had this brilliant product idea. She was sick and tired of opening the door for her cat to come into the house, right? So what she wanted to make was to make a small door for the cat to come into the house, but she wanted some AI system to help her detect if it's whether to let the pet inside the house or not, because she just wanted a cat. She didn't want the neighborhood dog to come into the house, right? So what I did, this is the problem, let the cat in, but not the dog. What I did, I called a photographer friend of mine. told him to take pictures of the cat and the dog, collected some training data. So I got a bunch of pictures of my cat and a lot of pictures of the neighbor's dog. I gave it to a machine learning module. It's called a convolution image net. You don't need to understand what this net is, just assume it's some machine learning model. And I used it to predict, and I got 100% accuracy. And I was very happy that, oh, I've solved this problem, I'm a genius. What happens? It detects the neighborhood dog as a cat, right? How did this happen? So if I look at it, so this is a common tool which we use. It's called plotting the error rates. So the y-axis is the error rate, and the x-axis is how much time am I training this for? How many epochs over which I'm training it for? So the training data, the data that I used to make this model, over time, the more I was training it, the more accurate my model was becoming, right? Because the error rate is falling continuously. But when I put unseen data, which the model has not seen, it's not been trained on, I can see that the error rate is falling, but after some particular region, say 25 epochs, it starts rising again. So what is the problem? The problem is overfitting, which is a very common mistake that people make. They really try to curve fit or overfit their model. So it's fit specifically for the data that I've given, but it doesn't generalize well to other situations. So this is a good example of overfitting. This is an example where I want to separate the blue and the red dots with a machine learning model. The black line is a good model. It's not 100% accurate. You can see some blue dots on the red side and some red dots on the blue side of the black line, but it's a good generalized model. And if you see the green line, it gives you 100% accuracy, but it's not a good generalized model. So this green line is something that I call overfitting, and the black line is a well-fit model, right? So again, it detected, I was very happy that I've solved the overfitting problem. I stopped at 25 iterations. So again, I gave the data. If you can see in this graph, 25 epochs is where I have to stop, right? Where the blue line stops reducing and starts increasing the break-even point. So I thought I'll get rid of the overfitting problem. I'll just use 25 epochs. If you see the model, I've given a stop epoch of 25. Still, it detected the dog as a cat. So what went wrong? I again plotted the error rate on the y-axis versus the number of data samples that I had, number of photographs that I had on the x-axis. And as I could see that the validation error is reducing, but it's not bottomed out at 400 samples. This is a problem which we call data insufficiency. You haven't given enough data to your model. You have very little data, training data, for the model to be able to learn or understand your problem. You can again correlate this to the ML model that I showed you versus the algo graph, where in the first 1 year, the ML model is lagging behind the algo model, right? Not enough data. Great. So I collected a lot more data, called my photographer friend, take 1,000 more photographs. He took the photographs and then I plotted the same graph. And I saw that somewhere around between 500 to 750 photographs, the error rate kinds of bottoms out. So voila, it predicted the dog as the dog. So I'm very happy. But the next day, it predicted the dog as a cat. What went wrong? So if you can see what I was doing, all the photographs that my friend had taken of the cat were all indoors. And all the photographs that they've taken of the dog are all outdoors. So instead of learning cat versus dog, the model learned indoor versus outdoors, right? This is called data leakage. What data leakage means is you're exposing the machine learning model to something you don't want it to learn inadvertently most of the times, right? And therefore, the machine learning model learns something besides what you want it to learn. So what did I do? I downloaded a dogs and cats database with dogs indoors, outdoors, cat indoors, outdoors, gave it to my machine learning model, built the model, and I was very happy because it detected the dog as a dog, even if the dog was indoors. I was happy. I put my prototype in production. It worked beautifully for a couple of days. It let my neighbor's cat in. Sorry, it let my cat in. The cat is resting, aram se in the house. And then one night, this is what happens. A raccoon breaks into the house and destroys the entire kitchen, right? Non-stationary distribution. This is the problem. So I had given my model cats and dogs to train. Now, when a raccoon comes, this is a data point which my model has never encountered before. So what my model tries to do is it says the raccoon is much closer to a cat than to a dog. So I will classify it as a cat and I will let the raccoon in the house. So a lot of times this happens. You have distributions which are not stationary. There are unseen values which come up. So, you will face these problems. So what I did to solve this problem, I loaded an others class. So I got raccoons, I got squirrels, I got birds into the model, and I taught my model to distinguish my cat from the rest. This is what happens after a week. It lets all my neighborhood cats at home and they eat all my food. How did this happen? This is a problem of solving the wrong problem. Okay, I was trying to make the machine predict cat versus the rest. Although what I wanted to do was my cat versus the rest, right? It sees all these are cats, it lets them in. But that's the wrong problem. My cat versus the rest is the right problem. Okay, I'm not going to get into how to solve these problems. Another common problem is outliers, right? If you can see the blue dots, there's a one outlier which is red. Now, if I fit a simple linear regression line, the green line which is tilted towards the left is what comes out as the best fit model. But actually what I want is the blue line which is tilted towards the right as the correct model. So what you have to remove outliers, right? This is a common problem which people overlook. Although it seems quite simple when I show you in the graph, but you'll make this mistake. Another problem is linear versus non-linear problem, right? So the graph on the left A, I can use a linear model like a linear regression line to kind of differentiate between the green and the blue dots. But graph B, I cannot use a straight linear line. So the graph B has to be solved with a non-linear algorithm and the graph A has to be solved with a linear algorithm, like a linear regression model. So bottom line is machine learning is powerful, but there are many ways to screw up machine learning if you're a bad data scientist. But the good news is all these are avoidable.